Okay, so this is going to be a short lesson. There's just one concept. I just wanted to give it a little room to breathe on its own, which is why this is just a one short little thing. I'm going to discuss the concept of isomorphism. Now, isomorphism is it's a fancy sounding math word that you'll hear in all different math settings. It always means the same. It means two mathematical structures that are essentially the same. I'm not speaking precisely at the moment, but we'll make it precise in the context of graphs shortly. The idea here is that with most mathematical structures like a graph, your object is made based out of sets, and the elements in these sets have names, they have identities, maybe they're integers, maybe they're letters, who knows what they are. But for instance, in graph theory, it's possible to have two graphs that have exactly the same drawing. They look the same, but they just have different names for the vertices and the edges, right? And that's going to be what isomorphism is. So isomorphic objects in mathematics are objects that maybe they're made out of sets, and maybe some of the sets have different elements, but they're essentially the same. You could get from one to the other just by renaming things. And I'm starting here back on this page that I was on last time because it's going to be easiest to sort of say this in the context of the drawing that we had before. I'm actually going to erase a couple things here. So this is going to be my graph G. Let me see if I can. Let's just cut that. Okay, so here's a graph G. Let me give you an isomorphic graph. So there, oh, maybe I should drag this G over. Okay, so there's G. Here's going to be a graph H, and what I'm going to do with H is, well, I'll keep exactly the same drawing, but I will just change the names, right? So maybe I'll color the vertices using, I don't know, capital letters. Here's W and X and Y and Z, and here can be Q. Why not? And then I'll use some numbers for the edges. This will be 7. I won't even use consecutive ones. How about pi? Why not? And 14. Okay, so these are just silly identities. What I'm showing you in this figure right now are two graphs. There's a graph called G and a graph called H. Those two graphs are not equal. Equal in mathematics always means the same thing. It means the two things are identical, right? When you write 3 plus 3 equals 6, you've got an expression on the left, expression on the right. They both evaluate to a number. Those two numbers are identical. They are both the number 6. In order for two graphs to actually be equal, they would have to have exactly the same set of vertices and exactly the same set of edges and exactly the same incidence relation. That can certainly happen, but we know what we're talking about when we're doing graph theory. We don't really care usually about the actual identity of the vertex. What we care about is the structure of the graph itself. And that's what's captured by the concept of isomorphism. So when we say that two graphs are isomorphic, we mean that the same drawing works for both of them, but possibly with different names on the vertices and edges, right? So we mean that there's a way of getting from one graph to the other graph by just renaming vertices and edges. And that's all it means for two things to be isomorphic. And this is the same thing you'll find everywhere, all over in mathematics, due to the same phenomena. Lots of times we have kind of higher order structures that are made out of sets. Those higher order structures can only be equal if all of their ingredients are exactly identical. But lots of times they are essentially the same. They have the same structure, and that's what isomorphism is. For graphs, this is what it looks like. I will sort of say in words here what I mean by, I'll say the formal stuff in words here, it is appearing in the notes, of course. I'll say that we're not going to spend a lot of time talking about isomorphism. It's kind of not our game in this class. Mostly what's going to happen here is I will tell you, here I have a graph that has property A and B. I want you to prove that it has property C, right? So a lot of what we're going to be doing is proving that certain properties of graphs grant us other properties being true. We want to understand structure of graphs. And we're not going to focus a lot on the identities of the actual vertices and edges, but I do really want to get this concept in place at the start because it does allow us to talk properly, and it is a good thing to understand precisely. So now let me just say very briefly in words how we would formalize this, and this is what you will find in the notes. So I'm saying these two graphs G and H are isomorphic because you could get from G to H by just renaming things. Or similarly, you could get from H to G by renaming things, right? And you can see exactly how you want to rename things here. And that renaming, if you wanted to capture it mathematically, would be captured with a bijection. So the formal definition here, maybe I'll just write a couple of words. There would be a bijection from the vertex set of G to the vertex set of H that would tell you, well, vertex 1 is going to be vertex Q, and vertex 2 is going to be vertex W, and so on. And similarly, you would have a bijection from the edges of G to the edges of H, and that would send edge A to edge 7, and it would send B to 1, and so on. So if you wanted to formalize, and as I've written in the notes, if you want to formalize the concept of an isomorphism between two graphs, you would say, well, there's a bijection between the vertex sets and a bijection between the edge sets, and that preserves the incidence relation, right? The key feature here of this bijection is that, for instance, vertex 1 in graph G is going to be incident with the edge A. And if you look at what happens under this mapping, under this bijection, well, 1 goes to Q and A goes to 7, and vertex Q in H will be incident with edge 7. And so this is what the formal definition is. As I said, we're not going to spend a huge amount of time with this, and I'm very happy if you're starting out just with the picture of what it means. G and H are isomorphic graphs if you can get from one to the other by renaming things. And that's going to be it for this one.